heat tolerance in wheat is possibly one of the biggest challenges. What we can observe and what we know is that with increasing temperatures, in particular during the night, the wheat growth is going faster, and that means we have less time to fill the grain. And we are here in Mexico, here at the moment we are here in Mexico, and over the last years we have seen that for every degrees the night temperature goes up, we lose about 6 to 7% of our yield. If I compare 2013, which was one of the cooler years here in Mexico, with 2015, which was the hottest year on records here in Obregon, the yield reduction was about 2 tons per hectare. Now that is a dramatic reduction, and we need to address this because it will get warmer, and so we need to see that we identify wheat varieties which can cope better with this problem. Many people will associate heat with developing countries, but heat is a problem basically in all wheat producing regions wherever wheat is produced. For example, great farmers in the Great Plains, they know that hot winds can really cause tremendous problems on the grain field. In 2003, French farmers lost about 1/4, 23% of the wheat production due to high temperature. And we also know that, for example, in the UK, increasing ambient temperature will cause increasing problems. So we have these areas where people don't think about, but where wheat responds with yield reduction. And then, of course, we have a tremendous problem in the developing countries, certainly due to high temperature. And the countries which are very much affected is South Asia, very much, and then also North Africa. One of the biggest problems for wheat breeding programs is to develop varieties which have all the traits farmers are interested. And this is a real challenge, in particular for a program like CIMMYT's wheat program, because we get a lot of special project funding which each allow you to work on a specific trait, but a variety is not the sum of traits, it's the product of traits. And what does this mean? A farmer looks at a variety, and the variety has to have, let's say, it has to have yield, it has to have drought tolerance, it needs heat tolerance, it needs rust resistance, it needs septoria, it needs white grain color, and it needs good grain quality and good processing traits. If any of the traits is not in that variety, the farmer will not grow it. Now, if you are as a breeding program, we need to breed for all these traits together. And that's why the delivering genetic gains in wheat is, I think, a very, very interesting and could be a model, because it provides you funding to deliver cultivars which have the complete package, and that allows you to work on all the traits in parallel. And I really see that the DGGW, delivering genetic gains in wheat, will allow us to do this much more efficient. The developed and the developing world produce about the same amount of wheat. We also have about the same average yield. It's about a little bit above 3 tons. But there are fundamental differences between wheat farmers in developing countries and the developed world. In the developed world, you have relatively big farmers, mechanized. In the developing world, you have mostly farmers which have less than 3, and many have less than 1 hectare. A farmer in the developed world which has a big farm, he will grow different varieties as a risk insurance against unknown weather conditions. So he will grow varieties which mature early, others which late, so they adapt to the changing conditions. A farmer in the developing world usually can only afford to grow 1 variety. And that's why it's extremely important that the variety this farmer grows is buffered against changing environmental conditions. So these farmers need lines in a good year with rain. They need to have high yield, but if there is no rain, it needs to have drought tolerance. It also needs to be buffered against heat, and it also needs to have a very good package against disease resistance. Because the smallholder farmers usually cannot afford to spray against diseases. So they rely on the resistance in the varieties, and that's why it's so important that we provide them a complete package of traits, because that only assures that these smallholder farmers have a secure harvest from wheat. On one side, on the breeding side, we can employ some new technologies. For example, genomic selection would be one. We also have technologies where we can grow several generations of wheat per year. So these are the interventions on the genetic side where we possibly can shorten the breeding cycle from a cross until a variety is released by 1 or 2 years. Then also what we will do is we will start the testing of varieties much earlier and start the seed multiplication much earlier. Traditionally, seed multiplication by national programs start when a variety is released. What we will do is we will start the seed multiplication when a line is going into registration trials, so that at the time of release we will have a reasonable amount of seed, and that will bring the seed again maybe 3 years faster. So I see the potential to shorten the current cycle from crossing until a variety reaches farmers' fields, which is currently around 15 years, to really bring this down to 10 years. We currently have the Dr. Borlaug shuttle was in Mexico, between the north of Mexico, Obregon, and central Mexico, the highlands in Toluca and Mexico City. What we will do is we will expand the testing by establishing phenotyping platforms where we will invest in locations where we know that a specific trait is very dominant. So we have started now to have a heat tolerance, screening for heat tolerance in Sudan, because there we have very high temperature and very dry. We look into the possibility of establishing a heat tolerant platform in Bangladesh, where we have heat but very humid, which is very, very different, well, for humans and for plants. We also have already a platform operating. The biggest one is in Kenya for rust. We also have one in Uruguay, which looks into multiple diseases, leaf rust, septoria, and fusarium. We will also have a platform in Tunisia operating for septoria. We look into the option of establishing a platform in Morocco, again for heat and drought combined, and in Egypt for yield potential. And in India, we have, through the Borlaug Institute for South Asia, access to environments where we can screen for yield on one side, but also for heat and for nitrogen use efficiency. So all this, if we put this all together, we will have a network of phenotyping platforms which allow to generate very precise data, because these precise data are needed then for the molecular geneticist to identify the underlying QTLs, or ideally identify the genes which are responsible for more efficient varieties. I really think that the delivering genetic gains in wheat faster is a new approach, because the donor has agreed to fund breeding as a program and not as something which is a single component. And this really will help us to deliver varieties much more efficient, much more faster, because in this case we can allocate the resources where we know we have the highest return and where is the biggest need. And we, based on our experience, make this decision, and not a donor who is favoring a specific trait, which may not even be very, very important for the overall wheat improvement. So I'm really looking forward for working with this new project.